So if you're building with Google's Agent Development Kit, you already know how incredibly powerful it is. But you probably also know that as you scale up, from one agent to 10 or even 100, things can get messy fast. And that's exactly what we're going to tackle in this explainer, how you can go from that all too familiar AI agent chaos to a really organized production-ready system. Okay, let's dive right in. Here's our game plan. We're going to start by really nailing down the problem, and then we'll introduce the solution, the Reactive Agent Hub. From there, we'll break down its core principle, see how you actually build an agent's brain and its shell, look at the massive payoff, and then finally, see how this whole thing lets you build an entire agent ecosystem. All right, first up, let's talk about the problem, because I'm willing to bet this is a story that's going to feel, well, very familiar to a lot of you developers out there. Seriously? Does this sound familiar? You start with one brilliant agent, then another, and pretty soon you've got a dozen of them, right? Each with its own separate JSON file, its own deployment quirks, its own operational needs. It's just a classic case of complexity creep, and before you know it, the whole thing can feel completely unmanageable. Yeah, this is what I'm talking about. In the old way, every single agent is its own little island. You've got prompt logic all tangled up with runtime settings, which makes any change feel super risky. There's no standard way for them to talk to each other, so they're all siloed. Cost and performance, total guessing game. And every edit you make feels like a high-wire act with no safety net. This is the chaos we need to solve. So, how do we fix this mess? Well, the solution brings a totally new philosophy to managing agents. It's really all about applying an industrial strength process to the creative work of building them. And here it is, the Reactive Agent Hub. Now, the key phrase you need to hear is Agent Factory. Instead of handcrafting every single agent from the ground up, you create standardized, reusable templates. This lets you just stamp out new agents that are consistent, totally reliable, and governed by one central set of rules. And the magic behind this whole thing is this really powerful idea, the separation of concerns. On one side, you've got what we call ADK cognition. That ADK is the Agent Development Kit, and this is all about the agent's intelligence. Think of it as its brain. Then, on the other side, you have reactive ops. This is the agent's body, or its production-ready shell. By keeping the brain and the shell completely separate, you can tweak them independently. And that right there is the key to unlocking real safety and scalability. And you can see how that separation makes for a super simple, repeatable workflow. Step 1, you define the brain, the prompts, the model. Step 2, you set the operational shell, the resources, the timeouts. Step 3, you publish it A to A, which just stands for agent to agent, so other services can find out what it can do. Then you place it in your org structure, and finally, you register and run it. It's just a clean, logical flow from idea straight into production. Okay, let's zoom in on that first super important step, crafting the agent's brain. This is where you define what your agent is and what it actually knows. So here, inside the ADK config tab, we're really defining the agent's core identity. That system prompt, right up at the top, that's its personality, its role in the world, and right below that, the model configuration decides which LLM it's going to use, in this case, Gemini 1.5 Flash. This is literally the heart of the agent's intelligence. But a grain is way more than just raw knowledge. In here, we shape how it thinks. The memory settings, for example, control its ability to remember past conversations. And the reasoning configuration, that lets it use these really powerful techniques like chain of thought, which basically just tells the model to think out loud and break down big, complex problems into smaller, logical steps. It's pretty cool. Okay, so we've built the brain. Awesome. Now let's give it that industrial strength body it needs to operate safely and efficiently out in the real world. Let's build the production-ready shell. This is that other side of the separation principle we talked about. See how we're in the reactive config tab now? From here, we can set resource limits, define the number of CPU workers, set specific timeouts, and we can do all of this without ever touching the system prompt or the reasoning logic we just configured. For stability and for cost control, this is an absolute game changer. So, what does this all add up to? When you combine a really well-defined brain with a robust operational shell, the result is a total transformation. Let's take a look at the payoff. Honestly, this before and after table says it all. You go from a mess of ad hoc JSON files to a single versioned template, from mixing up prompts and runtime settings to a strict separation.
from agents being hard to find to them being automatically published with a clear interface. We're replacing risky edits with safe rollbacks and unpredictable costs with per-agent quotas. It's a fundamental shift from chaos to control.
So this all boils down to 5 massive benefits. First, repeatability at scale lets you build entire fleets of agents from just one template. Second, you get real governance and safety through versioning and guardrails. Third, you gain direct control over your costs and performance. Then there's environment portability, and this is huge. You can deploy the exact same brain to dev, then staging, then prod, just by swapping out its shell. And finally, all of this means you can experiment much, much faster and more safely. But the real power, the true magic, comes when you zoom out. Because this isn't just about managing one agent a little bit better. It's about creating an entire collaborative ecosystem of agents that can all work together. The Hub lets you build these manager-worker hierarchies, where a manager agent can delegate tasks to its specialized workers. And because every single agent publishes its skills through a standard agent-to-agent or A-to-A interface, they become discoverable and callable by default. This makes true composability possible, where maybe your platform team owns the operational shells, while your product teams can just focus on crafting brilliant agent brains. So I guess the final question is this. You're already building all-in agents with these incredible cognitive abilities. You're giving them brains. But are you also giving them the robust, scalable, and manageable ecosystem they need to not just survive, but to truly thrive in production?